As we go into topic 4 now, this is going to be a lesson on special products. Now again, the word product implies that you're going to multiply something, and that's why these are called special products, because there's a special way of doing it. And the first one we'll look at is the FOIL method. Then we're going to square a binomial. And then we're going to multiply the sum and difference of two terms. And then we're going to use special products to multiply binomials. So there's a little background. To start us off, we're going to do the FOIL. And the FOIL is an acronym simply referring to the first of the binomials that we have in each of the sets, the first member. The O will be the outers, this one and this one. The I is for the inners, this one and this one. And then the L is for the last of each of these. And you'll notice that there are like two little lines underneath it indicating that everything has been multiplied. So the FOIL is just a sequence in which you do something. And in this case, multiplying a set of binomials. So let's get started. Now often people, when they start, they have some little configuration that looks like this. First, x squared. Outers, a negative 12x. Inners, positive 7x. And then last, a negative 84. Now notice, as a result of this, we ended up with two terms in the middle that are like terms. So we have to simplify that by getting x squared. This is going to be a negative 5x, and this is a negative 84. Now, as we mentioned earlier, this later we're going to ask you to factor back into that. So this is a product of two binomial factors. And you might say, well, where are we going to use this? Well, just a little aside. If we equal this to 0, we now have what is called a quadratic equation. And we're going to solve this quadratic equation by factoring this. And you may recall this from high school algebra. We're going to equal each of these factors to 0. And we get then x plus 7 equals 0, or x minus 12 equals 0. So here x is a negative 7, and here x is a positive 12. Now if you put those values for x in here, this will equal 0, and this one will make it equal 0. So a technique we're using, here we're starting off very slowly just to get you to multiply these so you can get a trinomial. But keep in mind later we'll be factoring and then later solving equations. We don't do that in this course. So again, we want the FOIL. First term, 6x squared. Outers, 15x. Inners, there's different ways you can do it, a negative 2x. And then last, a negative 5. So that when we combine like terms, we get 6x squared plus 13x minus 5. Now, in the previous lesson, we talked about multiplying, lining them up vertically, and then doing it by taking this and multiplying it by that, and this, multiplying it by that horizontally. The FOIL is a good way to do it in general. And again, will be needed for later things we do in math. Okay, first, a squared, outers, plus 12ab, inners, a negative 2ab, and last, a negative 24b squared. Like terms? And we have multiplied this binomial using the FOIL, a series of steps to get to your answer. Now this one gets to be a little tricky because it's fractions, but we'll just do it. First, x squared. Now we then get a plus, well, we get a negative actually first there. When we do our outers, a negative 6, let's put that right here. All right, negative 1/6x. Let's write that down properly. I'm going to put that over here for a moment because I'm going to do my inners and get a positive 3/7. So this is sort of together here. Well, let me put that somewhere here. Anyway, well, forget about that. Well, I was thinking of something, but I better not try to confuse anyone here. So our outers give us a negative 1/6x. So there it is, negative 1/6x. Our inners give us a positive 3/7x. And then our last gives us a negative, nothing will cancel. Oh, wait a minute, something will cancel here. We can do 1 there and a 2 there, so this is going to be 14. So let me check that out here. So this is a complicated one. So again, 3 will cancel with the 6. So on the bottom there, that's going to give me 7 times 2, which is 14. Okay. 7 times 2, 14. On the top is just 1. Now, we have to combine these, going back to an earlier section. Our common denominator here is going to be 42. Got to multiply this by 7, multiply that by 7, so that's a negative 7. Multiply this by 6, multiply that by 6, so this is 18. So now we can summarize. So x squared plus 11/42 minus x, don't forget the x, yes, x here, minus 1/14. Wow. And that is correct. Again, that was a pretty challenging one here. Now we're going to do the squaring a binomial. Now we had this before, a plus b, and through repetition is how you get to master it. Square the first term. So we'll square the first term. Multiply these two together, get a positive ab, and then double it. So 2ab. Multiply these two together, get 4x, double it, 8x. Square the last term. Square the last term. Okay, now we're going to square this, get 9x squared. Multiply these two together, a negative 15x, double it, and square this one. Now, again, I just checked the final a few days ago, and students had some of these, and what they did is they squared that and they squared that. They didn't put the middle term. Of course, they got it wrong. Oh, again, you need to practice and develop the recipe for squaring a binomial. All right, square this term, 25x squared. Now this sign is going to go there. Whatever sign is in the middle goes in the middle, by the way. And then it's 5 times 3 is 15. Double it, so this will also be a 30. But it's now xy. And we're going to square this. Since you're squaring it, it's always going to be positive. Plus 9y squared. Now square this. 7 times 7, 49. A to the 6th. Multiply these two together. It's going to be the negative 28, double it, 56, a to the 3rd. And now square this. Negative 4 times negative 4, a positive 16. Now, when we square a binomial, the product is called a perfect. You should write this in your notes. Square trinomial. Now, all of these are perfect square trinomials. What are some characteristics of them? Well, the first and last terms are all perfect squares. And the middle term, if we take the square root of this, we get 4 and double it, is 8. Here we take the square root of that, get 3. Take the square root of that, get 5. 3 times 5 is 15. Double it, you get the 30. That's basically what we were doing up here, and it works for all of them. Perfect square trinomials that come from squaring a binomial. Now, when you see something like this and recognize that it's a perfect square trinomial, later you'll be able to factor it into that, all of these. So this is the easy way because you already know what it is. You're just doing the process. Later, when you have to factor that, that's where it's much more challenging. But again, if you remember where things came from, that might be helpful. Okay, we're now going on to another kind of special product. And this one is where we have two terms in two sets of binomials that are exactly the same. What's here and what's here are the same. Here and here. The terms are the same, but what's different is the signs between them. One is the sum, one is the difference. Sum, difference, sum, difference, sum, difference. When I write it, I usually write the sum first. Here they're doing it the other way. Perfectly okay. Now, when you see an arrangement like this, these have a special name that describe what they are to each other. Does anyone know that? Well, they're called conjugates. So write this word down. Now, when you multiply conjugates, such as A plus B, A minus B, These are the sum and difference of the same terms, and we're going to multiply them. So we're looking for the product of these. Well, let's FOIL it. We get a squared. Our outers are a negative AB. Our inners are a positive AB. And our last, a negative b squared. Now notice what happens to the two middle terms. Since they're opposite signs, they are additive inverses of each other and become a zero. So when we multiply conjugates, we always end up with what we call the difference of perfect squares. So if you recognize that they're conjugates, you don't have to multiply the inners and outers because you know that's going to cancel out. So it's just the first, y squared, and the last, minus 9. It's just the first, 25x squared, and the last, minus 1. It's just the first, 4x squared, and the last, 9/25. Just the first, 100x squared, and the last, minus 49y squared. And what are these called? They have a special name also. They're called the difference of perfect squares. And when you factor the difference of perfect squares, you factor it into their conjugates. Again, some fortune of what will be coming in the future. Like a fortune teller, we're telling you what's happening. Okay. All right, now let's get some mixed practice in here. Squaring a binomial. Square the first term. Multiply these two together, 13n. Middle sign goes right there. Double it, 26n. Square 13. I happen to know that one. All right, what are these? Are they conjugates? No. So we're going to have to FOIL. So a times a is a squared. Now our outers, another way to do this is this way, is 11y, put it small, positive 11y, and it's ay actually, I guess. I can put it the other way too. And then the inners, a negative 4ay. So that's going to give me a middle term as I do this mentally of a positive 7ay for my middle when I do it mentally. Again, you may not be able to at this stage. And then finally your last, negative 4y times 11 will be a negative 44y squared. And we don't see them down there, but hopefully that's correct. All right, this one we're just going to FOIL also. T squared. This is going to be a 13, a negative 2 will give me a positive 11t. And this is going to be a negative 26. And it doesn't hurt if you're doing it mentally to go back and check it. So t times t is t squared. Outers 13t. Inners 2t. Add it up mentally, 11t. Multiply this, be careful of the sign. All right, now here we do have conjugates. So we know this is going to be 9x squared minus 25. No middle terms when we're dealing with conjugates. And this one, nope, we have to FOIL this here. This times this first is going to be positive 25 a to the 4th. Now my outers, this might be a complicated, so I'll write it out. A negative times a negative makes it a positive 35a squared b. Inners, a negative 50a squared b. And my last, a negative 70b squared. And I'm going to check myself here. Negative times negative made a positive. 5 times 5 is 25. A to the second, a to the second, a to the fourth. A negative times a negative gave me a positive 35 a squared b. That's good. And then a positive times a negative. See, I made an error here. 5 times 10 is actually 50 here, Mr. Paulin. It's not 15. And then we have this times this is a negative 70b squared. Okay, that looks better now. So we got like terms here in the middle. So this is going to be 25 a to the fourth minus 15. I knew there was a 15 in there somewhere. There you go. And let's check this. Yes, that one looks good here. Okay, now as we look at this, we have conjugates. So let me change colors here so it stands out. So 2x times 2x is 4x squared. No middle terms because they're conjugates. This is going to be a negative 16/49. So again, this is a perfect square. These are perfect squares. We have the difference of perfect squares when we multiply conjugates. And here we're going to use that special technique. Square this. Now we're going to go 4 times 13. And I'm not going to do that in my head. That's going to be 52. That's right. There's 4 suits in a deck of cards. 13, or anyway, 52 plus 52. So that's going to be 104 xy. Multiplying these and doubling it. And then squaring that, we said was 169 y squared. Okay. Again, this was the example I told you about that many students on the test got wrong. They forgot to put that middle term in there. So the rule is square this, multiply these two and double it, and square that. You have to practice that to get mastery. Okay.